2, 1, go.
Greetings, carbon life forms from throughout the universe. It's me, Scott Madry again, way down under in Adelaide, Australia, at the International Space University's Southern Hemisphere Summer Space Program. It's week 3, and we've just completed the core lecture series. All you alums know what that means. The exam's coming up, and we just had a fantastic final lecture by a new ISU lecturer, Charley Lineweaver, who's with us from the Australian National University in Canberra. Charley, welcome to ISU.
Thank you for inviting me here.
We're thrilled to have you. Tell us a little bit about yourself.
All right. Well, I work at the Planetary Science Institute at the Australian National University, and I did my PhD at Berkeley, and where we discovered fluctuations in the cosmic microwave background radiation, and my PhD advisor got the Nobel Prize for that in 2006. Since that time, I've been working in cosmology and in exoplanet statistics, so looking at all of the new detections of planets that are in orbit around other stars. The number of these things has gone up from 10 to 100 to 500 to 1,000 to now we're working on several thousand planets around other stars. As a matter of fact, it looks like every single star out there has planets around it. And I also work on the entropy of the universe. Where is the source of entropy? How quickly are we running out of free energy? What might the aliens be using for their energy sources?
Fascinating. And you spent a little time in Strasbourg, the home campus of ISU, isn't that right?
That's right. I was there as a postdoc after I graduated from Berkeley, from 1994 to 1997. I was in Strasbourg.
Oh, fantastic. And tell me, what's the biggest difference between Berkeley and Canberra?
The biggest difference between Berkeley and Canberra, well, at Berkeley I was doing my PhD, so I was a lowly PhD candidate under the thumb of George Smoot. In Canberra, I'm an associate professor, and I have my own PhD students, so I can put them under my thumb.
Fantastic. And tell me, what are your first impressions of what we're trying to do here at ISU?
Oh, I think it's a very lofty goal. You're trying to get together the world's, future leaders of space programs from many, many countries and get them to know each other, to cooperate, and to figure out how humanity in general can take advantage of space, explore space, without fighting over it, without going to war. And I think that's one of the most noble things you can do.
Well, tell us, you gave our traditional last lecture on the origin and fate of the universe, so where's it all heading?
Well, just you can't get away from the second law of thermodynamics, which means that we're headed for a heat death. However, the universe still, you and I are going to live 100 years or so, and the sun has got another 4 to 5 billion years left of hydrogen in its tank. And so if, from human perspective, it's a long, long time. But it looks like the sun's luminosity might increase fast enough, and this is something I didn't mention in my lecture, that probably in 1 billion years, plus or minus half a billion, we will run out of water on this planet. And so we will need to find our technology. I guess Moore's law, if it's applied to rocketry, should get us to another planet before 1 billion years from now. So we're probably safe on that one. Whether the journey will be a long one, but maybe we can get up to half the speed of light in, 1 million years from now.
Wow, that's fascinating. And tell me, in your own research, what kind of work are you most directly involved in now?
Well, as I said, I have 3 projects. One is to try to analyze this increasingly large, increasingly beautiful, detailed exoplanet statistics. So trying to figure out what type of planetary systems are around other stars. Is our planetary system typical? Will there be Earth-sized planets, habitable planets, in the habitable zones around these other stars, yes or no? It looks like the answer to that question is probably yes. Once that question is answered, and it looks like it's going to be answered in the affirmative, the next step will be, is there life there? If these are habitable ones, there's water on them, there's all kinds of, there's amino acids falling from the sky, filled of, carbonaceous chondrites with amino acids in them. All of the seeds for life look like they are ubiquitous, and so the question is there life there? That's going to be the next big thrust for the astronomy of astrobiology.
Wow, that's really fascinating. And of course, we're still trying to search for intelligent life right here on our own planet as well. So Best of luck to you in your research. Thank you so much for coming to ISU. We look forward to having you come back again.
Well, it was a pleasure speaking to so many intelligent, bright students.